All right, let's get to it. So these systems that we're going to do today is the 13th. By the way, tomorrow's Valentine's Day, so I have to pause the recording because I can't say this on the recording. Done. So these are special systems, I guess you could call them. These are of inequalities. So you yesterday learned how to solve and graph systems, solid line, dotted line, shade above, shade below. So these four examples today are dedicated very specifically to systems that don't look like the ones we learned yesterday. And these will now become a normal part. Like today's assignment, the new assignment is pretty heavy on these, but going forward, they're a little bit more sparse, but just I don't want any panic or whatever when you get one of the ones like today. Like as of today, they're in play. Got it? Okay. So our first example is going to be, I want to make sure I get my paper clip out of the way there. X minus 2y is less than 8. 2x minus 4y is greater than or equal to -8. All right, everybody got that down? All right, so I'm going to bring up a little graphy poo here. You guys have your graphy poos. Oop, where did it go? Is it there? Do you see it? It says it's here. Okay, I'm gonna make a new page. We're just gonna start over. How's that sound? Because I saw it. It went in and then it like disappeared. You guys all saw that, right? Okay, let's try again. There, see? Little fella. You little prankster. All right, so our first math problem was x minus 2y. So what are we gonna do with this? Yeah, let's move that x to the other side. So we're going to be left with negative 2y is less than what? Negative x plus 8. Right? I don't want to put those together or something silly like that. And then what do? We're going to divide by negative 2 because, of course, we're not done yet, right? We got the part that has the y by itself, but that's only job 1. Final job is to detach whatever number is multiplying. We've done this probably 500 times this year. And we're left with our answer, which is y is what? Greater than. Got to switch that sign. Good. What's our slope? Good job. And what's our y-intercept? -4. I like all this. So this one is ready to graph. All right. So I'm going to get rid of some work here up on my board, and I'm going to move this up, and then we're going to basically repeat that process again. And the second one that I gave you was 2x minus 4y is at least -8. You might already be ahead of me. What do we do first? Absolutely. So we're still left with that minus. It becomes a negative now. 4y is still greater than or equal to. What's our right side going to say? Like it. And then what do we divide by? Good. I do not avoid negatives when I teach. I want you guys to be good, and you guys are good. I mean, I'm trying to work out all the kinks, and so I'm just going to inundate you with problems where your skills and rules and stuff get tested. So it's not an accident. So we get y is what? 1/2. No. Oh, I had time to take a sip of coffee while you guys calculated 8 divided by 4. That was a little rough. All right, we're going to take this bad boy and we're going to move it up here, and now it's time to graph. Listen, I got to ask, it's obvious, but what do you notice about these upcoming lines? They are going to be parallel, right? You guys both said the same thing. They have the same slope, which indicates that they're going to be parallel to each other. This hasn't come up yet. I left them out yesterday on purpose. So I'll color code this. Let's do the one with the red dot next to it first. So where are we going to start the red dot one? Red dot one. You're fine. So down four, and then the slope is up one, right two, up one, right two. And I don't make dots along the way. I just I like my pen keeps following the down one, left two, or up one, left two, or up one, right two. And then I just wait and make the line later. So, or the points, I mean. How's my line? Is it okay? You should hate my line. Should be dotted. Very good. So when you made yours, I hope you remembered that. And it's no big deal if you didn't, you can just go back and fix it. So which way will our shading go? Would it go? Above. Remember that we learned we don't want to shade yet. It's gets ugly and chaotic looking. So now it's time to graph our other line. And this one I'll use yellow. So where do we start the yellow dot graph at? Nice. So what you're going to see in this example is one of three possible scenarios. I do have four examples because one of them kind of can go both ways, but you're about to see one of three things that can happen with parallel lines when we're doing inequalities. So this one also has a slope of 1/2. So I'm going to just make a line. Like this. And this one should be solid, which is good news. And where does the shading or would the shading go on this one? It'll go below because it does say is less than or equal to. So we're going to shade below. So this is it. Scenario number one. You'll want to keep track of these. When two shadings push towards each other like this and they're parallel, I call these the sidewalks. To me, it reminds me of like a perfectly rectangular long strip of concrete. The way your shading is going to look on a sidewalk problem like this is like this. It will go forever in both directions, but you don't really need to indicate that. The fact that your lines go forever, how I showed my shading is perfectly sufficient for a sidewalk problem. So if you have two parallel lines and one pushes up and one pushes down, like if they push, that's a bad way to say that. If they push towards each other, then you get the sidewalk. Any questions on that one? All right, let's do another one. So again, that is possibility number one. On the last couple, no, never mind. I'm not going to say that because I might take it back. Let's do this one and this one. First one ought to be really easy to tackle, right? This top problem, what do we do? That's all, and it's done because it's a positive y. So we get y is greater than moved x, so negative x plus 3, right? And then I can take the original problem and I can replace it with the graphable version of itself. Second one, there's a little bit more meat on this bone here. What would we do on the second one? I would add the 2x to the other side. Yes, I would move it. So when I move it, the negative 2y is still over here. This is still a less than, but when I move this negative 2x, he gets renamed as positive 2x. And then what do I do? Perfect. And we should be to the point now as a class where about 100% we're red flagged here. Like we know when that division by negative happens, that should be just a conditioned trigger response. Like I'm going to switch a sign. So we're going to be done and say y is what?
Greater than.
Greater than. And what's my slope? Good. As I've been saying since August, if you want to put -1, you can. If you just want to put negative x, you can. Right? It's not wrong either way. All right, so now we're ready to graph, and you can see why this problem is in today's notes because the slopes are the same. So we know by definition that yet again we have two parallel lines. So let's start with the one with the red dot. Where would I begin that graph at? Nice. And what's his slope? No, that'll give you Yeah, you could go down and right or up and left, but just make sure, come hell or high water, make sure that your graph tilts the right way. Negative, of course. All right, stick some arrows on there and let's indicate where the shading would go if we were actually going to go full send on the shading. Would it go above or below?
It would go low.
It says is greater than,
So above.
so above. And so my little arrows are going to point upwards. Hmm? It would be a dotted line. Thank you, Justice. I appreciate that. Got to keep me in check. Thanks. Okay. How about our second line? I'll just use the same color again, yellow. Let's go yellow dot guy. Where does he start at? Thank you. What's his slope? So obviously it's going to run parallel to the other guy because its slope is also -1. So we're going to have another line that looks like this. And this time I am not going to forget, thank you, that it is another dotted line. Where does the shading go on this one? This is the second scenario. This is the one that I think confuses people the most. Um, Let me ask you a question now that we've got our graph constructed. If I put a point right here, the purple dot, does it solve the system? But it's above the yellow.
It's not above both.
Correct. The thing about systems is you guys seem to have gotten the memo, so good for you, is that but everyone has to be happy, right? That purple dot is no good. Where will my final shading actually go?
Top right area.
Above this line. Correct. So the thing is, you might say, well, that's just the shading for the red line, but in reality, it's the shading for both lines. Because if I'm going to make both situations happy, I have to be above red, because then by default, I'm above red and I'm also above yellow. Does that make sense? That is the second scenario when you have parallel lines, is they can wash towards each other, and then the further one away is basically the boss. Would anyone like to guess what the third situation is?
Very bottom.
Where they face opposite directions. Very good. So sorry, I mean, spoiler alert, but you probably knew what was coming anyway. So let's do one more example. And honestly, I don't know if we need to do the fourth. So I think I'll probably stop after this. 3x plus 4y is less than -4. And then -6x is less than or equal to 8y minus 48. Stuff like this would have scared us a long time ago in a mathy way, I don't know what to do, but you guys know the battle cry. Get y by itself. It gets us through so many things in math. So let's talk about the top one first. What would we do? I'd move my 3x, right? So I'd have 4y is less than a now -3x minus 4. And what would we do to finish the job? Absolutely. And this will be our ready to graph answer. Should I change my sign? I got some negatives over here. No, I'm not dividing by a negative, so I keep it as less than. What's my slope? Perfect. What's my y-intercept? Thank you. So I can now remove from my board this top problem, and please don't erase your work. I do this just to keep things clean for us, but there is number or the top one ready to go. The bottom one is a little wonky, eh? What is a good plan of attack here? I'm not scared. Sure. Like just literally have them switch places. I got no issues with that. If I'm going to do that though, I have to remember that they switch sides, right? Absolutely. Good thinking. Yep. And it's one of many ways you could have attacked this problem, but I like that, sir. Like, we're going to take the 8y and make it negative on the left. We're going to keep our sign facing the same way because we're not flipping the problem. We're not reading it backwards. We're just moving a couple dudes. And then we're going to move 6x to the right like this. I like that move. That puts it right in the sweet spot of where we like everyone to be. The y, the x, the number, it's all delicious. Now, what do we do? Absolutely. Bless you. It does, because we're dividing the red number is negative. So we have y is greater than or equal to, what's the slope? Negative 3/4. Not that that's a surprise. And the y-intercept? +6. So again, we find ourselves with all of the work done, right? That's all the algebra work that has to go well. And now it's time for graphology. And of course, they're parallel, so it's not like that's a secret. Let's talk about the top one. I'm just going to kind of talk you through it. Tell me if you disagree. I'm going to start by going down one. And then because the slope is negative 3/4, I'm going to go down and right a bunch of times. I'm going to go down 3 for every 4 I go to the right. And this line is dotted. Which way would the shading go? Below. Very good. So I'm going to draw some little indicator arrows. And then my other line, I hope you agree, yellow dot guy is going to start at up 6. And his slope will mimic the slope of his buddy, down 3 for every 4 to the right. Down 3 for every 4 to the right. And there's our lines. If we were going to go full send on the shade, where would it go? Yep, clearly at the end it says y is greater than, and so the shading is going to go above. And it does have the or equal to, so I don't need to make this line dotted. So as you predicted, because you've been around my math lessons long enough to know how I roll, this is the only other possible thing that can happen. Your lines are either going to press towards each other to make the sidewalk, they're going to press in the same direction, whereupon you choose the one that's further along in the flow, or they're going to press away from each other, in which case, what gets shaded? Thank you, Jeff. Nothing. There is no shading in this problem. There can't be, because you cannot at any point ever say, hey, look at me, I did it. I'm above the yellow line and also below the red line. You cannot be in two places at once. Therefore, the answer to this problem is an empty graph, and we need to explicitly state that there is no solution. You can leave your indicator arrows there if I mean, it's not going to bother me if you do. Now, if there were shading, then I would take points off. Then I would pitch a fit. But the little work arrows that we show along the way, it's okay if they just kind of stick around. Do you guys have any questions about this? Am I safe to assume you probably don't need another example? The only other thing I was going to show you, I'll shortcut it, and then I can save us all 5 minutes and you get more time to do your homework. The only other thing I was going to show you was another problem like this. I'll just save us a bunch of time. And I can tell you it was something like shading goes down and shading goes down. Well, what am I doing in yellow for? Come on, man, get your head in the game. What would the answer to this problem be?
Very bottom.
Below the red. Good. So we didn't need a whole nother problem. I'm just hanging out talking to you guys. I realized that would have been overkill. So as long as your shading is above the further one or below the further one, then you can rest assured that you're making both inequalities happy at the same time, right? All right, so I'm going to pause the recording like I always do, and then I'm going to give you your assignment. And if you have any questions, then you can let me know. Sound good? All right, cool.